Alright, so all that's left is then let's use our newfound equation, which is force of friction is equal to the coefficient of friction times the normal force between surfaces, to solve a couple problems. So Dexter Ayus is running through the cafeteria when he slips on some mashed potatoes and falls to the floor. Dexter lands in a puddle of milk and skids to a stop with an acceleration of negative 4.8 meters per second squared. Dexter weighs 780 newtons. Determine the coefficient of friction between Dexter and the milky floor. So let's see what they gave us. They told us the normal force due to Dexter. They told us an acceleration, and they asked us for the coefficient of friction. So the problem here is they've only given us one variable here, the normal force, and they haven't given us the total frictional force or the coefficient of friction, and they ask us to find the coefficient of friction. So, is there anything we can use to find the total frictional force? Well, it turns out there is. We know his acceleration. We know that force equals mass times acceleration. So for using this 780 newtons, we can find Dexter's mass. So force equals mass times acceleration. His gravitational force is 780 newtons, and that would equal mass times gravity, which is 9.8 meters per second squared. We divide both sides by 9.8. 780 divided by 9.8 equals 79.6 kilograms. Alright, if we know his mass, then we can use the FMA equation again. And we can say that for him to have an acceleration of negative 4.8 meters per second squared, for his mass of 79.6 kilograms to have an acceleration of negative 4.8, what must the frictional force be to slow him down that much? So the frictional force then will equal 79.6 times negative 4.8 equals negative 382. 0.08 newtons. So now finally we have our frictional force over here, and we can plug that into the equation and say that frictional force is equal to negative 382. I'm going to round this 0.1 is equal to the coefficient of friction times the normal force, which was 780. We're going to divide both sides by 780. And 382.1 divided by 780 equals negative 4.9. Or sorry, negative 0.49. Okay, and we can check our answer. They don't have negative written down, but that's because the coefficient of friction is a unitless measurement. So really it's just the absolute value of this. So it is 0.49. Okay, second question. Alejandra is attempting to drag her 32.6 kilogram golden retriever across the wooden floor by applying a horizontal force. What force must she apply to move the dog with a constant speed of 0.95 meters per second? The coefficient of friction between the dog and the floor is 0.72. So we know that the force of friction is equal to the coefficient of friction times the normal force. So one of the things we're going to have to calculate is the normal force of the dog. And since we're going to assume it's on a flat surface, we're going to say that force equals mass times acceleration. The normal force of the dog is going to be 32.6 kilograms times 9.8 meters per second squared. Therefore, the normal force will be 319.48 newtons. Okay, if she's going to drag the dog across the floor with a constant force, then she's going to have to pull with a force equal to the force due to friction. And we can calculate the force due to friction because it's equal to the coefficient of friction, which is 0.72, times the normal force, which is 319.48. So the force due to friction would be 230 and I've got 0.03 newtons. So if she pulls with a force equal to the force due to friction, then that dog will move at a constant speed. Alright, last problem. A 1,370 kilogram car is skidding to a stop along a horizontal surface. The car decelerates from 27.6 meters per second to a rest position in 3.15 seconds. Assuming negligible air resistance, determine the coefficient of friction between the car tires and the road surface. So, force due to friction is equal to the coefficient of friction times the normal force. They gave us the mass of the car, which could be used to find the normal force. They're asking for the coefficient of friction. We're going to need to determine the frictional force in this equation. So let's start and find the normal force of the car. The normal force of the car is going to equal the mass of the car, which is 1,370 kilograms, times the acceleration due to gravity, which is 9.8. Therefore, the normal force is 13,426. Okay. Next, I need to find the force required to cause this car's acceleration, but to do that, I'm going to have to find this car's acceleration in the first place. So I know that acceleration is equal to change in velocity over change in time. The change in velocity is going to be 0 minus 27.6 velocity final minus velocity initial, all over the change in time, which is 3.15 seconds. So my acceleration is going to be negative 27.6 divided by 3.15 equals negative 8.76 meters per second squared. Therefore, I know that force of friction that would be required to slow this car down to have this acceleration would have to equal its mass, 1,370 kilograms, times its acceleration, which is negative 8.76 meters per second squared. Therefore, the force due to friction between the cars and the road must be negative 12,000. And 1.2 newtons. Therefore, I can finally come back here and say the force due to friction must be negative 12,000 and 1.2, and that's going to equal the coefficient of friction times the normal force, which we found earlier to be 13,426. We're going to divide both sides by 13,426. And I get the coefficient of friction to be equal to negative 0.894. And remember, we don't need to worry about the negative sign with the coefficient of friction, so we just get 0.894, and the answer checks. So those are solving some problems with friction. I hope this lecture was helpful, and until next time.